Hello and welcome to my video on static electricity 2.1. So similar in concept to magnets that you've probably played with in the past, especially in elementary. We have opposites attracting and like charges repel. So opposites in magnets are north and south, but for us we have positive and negative. And like charges repel. So if it's double negative or if it is double positive, either one of those would repel. So like charges repel, opposite charges attract. Some materials like to give up electrons, becoming positive. Some like to gain electrons, becoming negative. But the main idea is that the electrons move, not the positive charges. So it either gives up or gains electrons, and that's how it becomes positive. So the positive charge can move from one spot to another, but it's because the electrons have moved from one spot to another. One electron is called or is given an elementary charge. This is the elementary charge. That number is 1.6 times 10 to the 19 negative 19 coulombs. Obviously an electron will be negative because it's a negative charge, but proton will be a positively charged version of the same thing. Conductors are happy to pass along charges like metal, water, plenty of other things are conductors as well. And insulators tend to avoid giving or receiving electrons like plastic, glass, wood, like that. We can either conduct charge from one object to another, or we can induce a charge. Conduction is simple. It's like you would with temperature. If you touch two objects together, they will start to exchange. So in terms of temperature, they would exchange heat energy, and they would balance between the two in terms of heat energy. For charges, if you touch them, they also balance, but they're going to balance charges. So conduction always balances the charges between the objects. So if both were one was positive to begin with and one was neutral to begin with, then both become half as positive at the end. Okay, or if one was positive and one was very, very, very negative, so like let's say positive 2, I'm just making up numbers here, and negative 10, well, then we have to find what it is together. So basically you add the two, and then you balance that between two different objects. So it's a negative 4 and a negative 4. It's halfway between 2 and negative 10. You can also think about this as an average. So 2 plus negative 10 divide by 2. So it's an average charge between the two objects. Okay, so it's always going to balance between the objects, and if we induce a charge, we can flip it from being positive to negative, negative to positive. We're going to talk about that. Inducing is really weird and really cool. So conduction, very simple. Okay, here's a little bit of an image for conduction. So conduction is if you physically touch the negative, in this case this is a negative charge, right? If you touch this here, then these negatives will hop over and it'll become negative in here. Okay? So very simple. Touching, negative charges move. Electrons transfer to the object, making it become the same charge. The same thing happens in reverse if it's positive. So let's just draw a positive thing here. If this is positive, then basically what happens, the positives don't move over, but what happens is that these negatives move this way and will balance out. And then overall, this will have less negatives and therefore it'll become positive. Okay, induction is cool because induction allows us to do something different. So if we bring this negative charged rod close, but not touching, close but not touching. Okay? If we bring it close but not touching, then what happens is this entire ball, maybe I'll just draw it to the side here. This entire ball, the negatives are repelled from the negatives in the rod, right? Because like charges repel. So if the rod is close with a bunch of negatives, then it pushes the negatives away from that side. Okay? Now what we do is we touch this with a ground. So we ground it. We give the electrons a path to escape. So then all of these electrons try to escape on the ground. Okay? The next step is we remove the ground. So once we remove the ground, it's just going to have the positives left over with maybe a couple negatives over here, but not very many because the rod is still, close by with negative charges. And then you remove this entirely as well, and now you're left with a overall positive charge. There might be a couple negatives left over, but overall it's positive. Okay, and that's by using induction. So we bring it close, but don't touch, and then we ground it. All right. And then positive induction, essentially just does it with a negative rod, right? So if it's a negative rod, that means on this side we're going to have the positive charges. On this side we're going to have the negative charges. Then you ground it, the negative charges leave, and you're left with an overall positive. Okay, on this one, if it's positively charged rod, then the electrons are attracted to that, and it's more positive on the other side. So when you ground it, what happens is the electrons actually go in this way, and they add more electrons in a bunch of places. So we add more electrons here because these are so positive, they attract electrons. So then you remove the ground and you're left with an overall negative charge. Alright, let's try a couple example questions, just talking about it essentially at this point. We'll have calculations more in the next couple videos, but in this one, just some example questions. Consider two identical pith balls. One is charged with a positive 4 microcoulombs. The other is charged with a negative 3.5 microcoulombs. If they're left close together and isolated from the rest of the environment, describe what would happen. So if you bring two pith balls together and let's say it's isolated, meaning nothing else is touching them, okay? They're just floating in a vacuum, no gravity, nothing else. No charges are leaking, anything like that. What would happen? Well, if this one was plus 4 to begin with, right? And this one was negative 3.5 to begin with, then what we're going to have is an attraction, first of all. So first of all, they're going to attract. Okay? Now, once they attract, at some point they're going to touch. Now when they touch, they're going to balance the charges because now it's conduction. Okay? So it's going to balance the charges. You're going to go 4 minus 3.5, and we're left with negative 0.5 total. No, not negative, positive 0.5 total. Now that 0.5 is going to be split across both objects. So each one is going to have a 0.25 on each of the two pith balls. So they're going to, in this step, we're balancing the charges. And I'll just say conduction balances the charges. Okay, so the first step is an attraction between the two balls. The second step is once they touch, there's going to be conduction. We're going to have a balance between the charges. And then once they're balanced, they're both a positive 0.5. So now, I'm going to just change that to be smaller. So now that they're both a positive 0.5, now they're going to repel. Because they're both a positive 2.5. Okay, so at the beginning they attract, then they touch, and then they repel. Okay, so that is kind of a description of what happens. We didn't do really any calculations other than what the charges are on them at the end. But I recommend you pause the video here and you try example 2 and 3 and see if you can solve them yourself. Okay, hopefully you did that. We're going to try example 2 together. Consider two identical pith balls. One is charged with +4 while the other is neutral. When they touch, what is the charge on each pith ball and what happens to them? So again, same sort of question as before. So at the beginning we have 4 microcoulombs. Okay. I'm not going to write that, I'm just going to say 4. And the other one is 0. Okay, so there is going to be an attraction here. Okay, when they touch, they're going to balance charges, and it's probably easier in this case to imagine what those balance charges would look like. 2 and 2 equals 4. So conduction, and then balancing the charges. So each is going to have 2 microcoulombs, plus 2 microcoulombs each. Okay, and then step 3, what's going to happen next? Well, they're going to have a repulsion. Because they're both positively charged. +2, +2 charge. All right. Hopefully that makes a little bit of sense. Let's continue on to example number 3. Van de Graaff generators use friction to build up, create a buildup of static electricity at the top. From my research, it seems that they generate a positive charge. I suppose you could design one that would do negative, but I think the main ones, the normal ones, do positive charge. If you touch a separate metal ball to the top of the Van de Graaff generator and then bring it close to a pith ball before touching the pith ball with your hand to the ground, then you remove your hand, then you pull away the metal ball, what is the charge on the pith ball? So we've described a process here. What is the charge going to be? When it's asking here what is the charge, it means is it positive or negative. Alright, so hopefully that makes a little bit of sense. Pause the video here, see if you can do it yourself. Okay, so here's the description. Okay, here's the Van de Graaff generator. It has a whole bunch of positive charges over here at the top. Basically there's a belt inside that kind of creates that, pulls the electrons down to the bottom. So anyways, it's positively charged up top, and then you take a separate object with a metal ball on a rod, and you touch the metal ball to the Van de Graaff generator. Essentially, what's happening is conduction. So that means this is going to become positively charged. Now, you take that separate metal ball and you bring it close to a pith ball. So now you're bringing that close to a pith ball, so it's positively charged. You bring it close to a pith ball that looks like this, but not touching, okay? And so what happens is the negative charges all pull to the one side. Okay, something like this. And then your next step is you ground the pith ball by touching it with your hand. So when you ground it, these negative charges travel up the ground, up your finger, to balance out whatever positives there were on that side. Then you remove the ground. So it's still going to look kind of weird with some positives over here and those negatives that came from your hand. Okay, it's going to look kind of weird at first because at first we've got the positive charges from or the negative charges still being pulled to one side. But when you remove the ball, the big metal ball, the pith ball at the end is going to be roughly balanced like this with all your positives kind of spread out. But an extra set of negative charges. So you can see there's much more negative at the end. Alright, I hope this video helped you understand static electricity in the basics of it, with opposites attracting, like charges repelling, conduction always balancing, and induced charges flipping the charge, as well as how to induce a charge. I hope this video helped, and good luck.